What's crack-a-lackin' people, and welcome to part 3.2 of implementing the NanoChat tokenizer. And let's jump right into it. We're wasting no time today, and we're implementing the following methods today. So we've already done save, but that was for the regex tokenizer. Now we have to do it for the NanoChat tokenizer, which kind of just adds the complexity of we do now have a directory that we need to save to that's provided by the class itself, and we need to use OS for that. And then also it's a tick token object instead of a regex object, but otherwise it's pretty simple. And then we have from directory, which just means load. And just one convention that is actually really important to note is that whenever you have a factory method, so a factory method is a method in Python which returns a class object, and that's when you put class method, this function decorator in front of it, then the convention is to say from underscore and the name. So in this case, when we make a pre-trained object, we'll call it from underscore pre-trained. So this is an important convention that you should know, and that's why it's not called load. Otherwise, this is just the load function from regex as well. And then we have two getter functions, which is just one line, so no need to stress about that. And from pre-trained, which as I kind of insinuated or intimated, it's just the same thing as load, except we load from the tick token library, which gives us access to models such as CL100K base, which is the GPT-4 model. And then we also have the last two, which are the most technically complex: render conversation and render for completion. So render conversation just makes a conversation, tokenizes a chat conversation, dictionary into token IDs, and then render for completion tokenizes a conversation for reinforcement learning, removing the last assistant message, and then just adding the assistant start tag to prime for generation. And we again have our principles. We're doing this to show problem solving with pseudocode and small examples, and hopefully doing this all in one take. So everything here, except this that I just added when I was preparing for this video, is the same as last video. So we can just get right into it. I was just pretty much just making sure that the from tokenizer method works, but we're not going to do that right now. One thing that we are going to do though is talk about the repr method. So where is the repr method? I implemented it in previous video. Yes. So I actually uncommented it. So the reason why is that, well, we didn't actually discuss the repr method in last video. So I'm going to jump off of the script right now and implement from pre-trained right away so I can show you how the repr method works, because we kind of want from pre-trained to be implemented so that we can print out the things that we load from tick token. So as I mentioned, since it is a factory method, we need the class method dictionary, decorator, not dictionary. If you want to pause and read this, then be my guest. And it was called from underscore pre-trained. Okay, and then what arguments does it take? Well, it is a factory method, so I should probably add the CLS object, which is essentially stands for the class. And we also need the tick token name, which is going to be whatever you input. So this could be GPT-2, this could be CL100K, it could be anything. And we first need to create an tick token encoding object, which is simply just tick token dot encoding with a argument being the tick token. Oh, I don't want to have quotations here. The tick, come on, give me that type hint. The tick token name, there you go. And all we have to do now is return a class object that has the encoder as well as the sequence separator string, which we really stressed on last video because it is not the same as the NanoChat library, which in the case of Karpathy's implementation uses beginning of sequence BOS, but since we do end of text, this means that we are going to be appending instead of prepending. Okay, so the from pre-trained method is relatively simple. There's just two lines, and now we are able to test the repr. So as I have it here, when I was preparing for the video, we have GPT-2 equals NanoChat tokenizer. Since it is a class method, it operates on the class and not the class instances, which the class in this case is NanoChat tokenizer. Dot from pre-trained on GPT-2, and then we will print. So here I've done one print, which will give us the special token set, but since I want the repr, right? For a repr, you just simply print the object. So I'm going to print GPT-2, and also I'm going to uncomment this so we can save this for slightly later. And you might be wondering, how did I get GPT-2? Like maybe the name is something else. As we know, it's called CL100K for the GPT-4 tokenizer. Well, conveniently, on the TikToken GitHub page, there is in the TikToken_ext extension, I guess, directory, a file called openai_public.py. And first of all, you can see here the special tokens that do exist within the framework for all of the tokenizers used. So not every single tokenizer will use these special tokens, but they will use some. In the case of end of text, they will all use this one. But for the other ones, if you're curious, FIM means fill in the middle, and this is for different mid-training objectives. But I'm going to stop blabbing. You can see here we have a pattern for regex splitting, and then now we can see all of the different tokenizers. So we have O200 Harmony. Actually, all of the names here are listed. So the reason why I put GPT-2 is just because that's what it's called. You could also choose any other set here. So let's also try R50K_base. I don't know what this tokenizer is or in what model it's used, but why not try it? And here you can also see some cool parameters. So this is the encode object itself. So the ENC object is actually a dictionary, which has these parameters: name, the number of elements in the vocab, the pattern string, which in this case is just this pattern string, the mergeable ranks dictionary, which tells us how we merge tokens together, how we merge byte strings together, and then our special tokens. So now that we have GPT-2 here, right? Let's come back down and print to see what happens. So I want to first clear so we have a nice terminal. And let's see what's wrong here. Encoding, missing 3 required keyword only arguments, patching, mergeable ranks, and special tokens. Okay, I think this means that I did something wrong. So let's go back to our from pre-trained method. Did I call the right method first of all? Yes, I did. Okay, that's fine. So CLS token name encode equals tick token dot. Okay. So since we already give it the token name, I realized that we're not using encoding. So where do we use encoding actually? Just so I can refresh my memory. Okay, yes. So we're using it here in the train from iterator method in order to create a tick token encoding with our own mergeable ranks. But since we already are asking for a model which is pre-trained, we don't use this method in the get in the from pre-trained method. We use actually something called get_encoding. So my bad. Now we should be able to retry it. Cool. So why? I think I actually uncommented the repr method. Let's go. So you can see the repr method is uncommented. So what it should do is tell us the name, which if we come back once again to the GPT-2 object, it is GPT-2. And let's also print special tokens. So I think that's what I was doing down below. So now if we print, let's first do a sanity check to see that we print the name GPT-2. Cool. So this is our own repr method, which prints the name. Otherwise, it printed that object string here. You can see that, which is not legible. So you want to have a repr method to, have a better representation of what your class object is. And then also we look at the special token set and observe end of text. And then if you come back here, what is the special tokens? It is indeed end of text, and it is this token ID. Of course, we didn't get the token ID because we didn't encode it, but if you did encode it, why don't we just encode it and see what happens? So let's do GPT-2, right? Since I haven't tried this myself, right? But since I have the call object, the call method set to self.encode, it should forward GPT-2 since it is a NanoChat tokenizer, directly to the encoding method, and then we should get the token 50256. But I could be wrong. Okay, so what's happening here? Invalid input type. It's a set. It's because I didn't index the set, right? Does it return a set of the special tokens when I call this method? Let's make sure. So I'm going to get rid of this and then comment that. Okay, so it does return a set. I'm actually kind of a noob. I don't know how we index a set in Python, but since there is only one element, I think we can just do pop. Let me see, does pop work on a set? Guys, we're in uncharted territory now. Okay, pop does work, and it returns the method and the element from the set. So let's try that now. Pop. Oh, what the heck? Why did it not encode by the special token? Okay, so what actually happened here is that the end of text string, right, was encoded as a normal string. And I think this is because we did not call the encode special for the tick token encoding method. So let's debug this, right? Let's debug it live. This is the intent of this series. So when we call GPT-2 just on the class object itself, we get this method which forwards it to self.encode, and self.encode comes here, and we don't have a append or num threads, so these conditions are all kind of vanished, and then we get into here, which would be true. So if instance text string, we encode as a string, and then this is why when we get the IDs here, it's encode ordinary, and this is very important to note, which is why we get the ordinary encoding of this end of text string, which would be this. So this is of course kind of a bug, but it isn't at the same time. It's in a quantum superposition. And why do I say that? Because there's no case in application where we would have our NanoChat tokenizer class being used and a special token would be encoded in this way. As you can see through our logic, we always add the special tokens after the fact, right? So you can see, right, if prepend or append, depending on which one we're doing, end of text or beginning of sequence, is true, then we just encode the special token, right? And then what do we do with append ID? We append it to the list itself. So we don't actually go through the encoding when we have our special tokens. We encode them separately and then come here and add them to the list a posteriori, so afterwards. So because of this, we can't just use the GPT-2 object itself to call encode. Instead, we should do, we have to do the encode special. Boom, let's go. So we do encode special. What does it do? I think it just calls the encode special, encode single token of the tick token encoding object. One thing we're noting is that this would also cache it, since we have LRU cache set to as decorating this function. And I assume that encode single token, right? If I highlight this, if it gives me the type, the function signature, it doesn't. This would handle special tokens, because we see here that 50,256 is the special token for end of text. That is so cool. So I got derailed by the video now. So what we're even doing here, we have to go implement save. So let's implement save now. And in the interest of time, I'm just going to copy paste save from the regex tokenizer and then modify it as necessary. And then you may be asking yourself, right? Why are we implementing this twice? Why don't we just use save from the regex tokenizer? It's because the regex tokenizer is simply, to reiterate, trained and then discarded. So we train the regex tokenizer to get that self.merges dictionary, and then we discard it, and now we only use tick token because it has the encoding decoding implemented in C, which is much faster for inference, but the training happens here. Since the training only happens there and the inference token use happens here, it does need its own save and load method. So what's the difference here? The difference is that, well, we have path, right? And I think that in the NanoChat, if I look to my notes, in the NanoChat repo, it's called tokenizer dir, which is the same thing as path. And we're still writing onto a binary, writing byte strings. And instead of pickle dumping this stuff, we just pickle dump self.enc, which is the encoding, the ticktoken.encoding object, okay? And I would like to remind you that self.enc is already a dictionary, right? If you look here, it is a dictionary of these key value pairs. So whereas prior to our save made a dictionary on its own, right? We don't need to make the dictionary in this case. And the last thing here is, where are we? Oh, pickle dump. The last thing to note here is nothing, because other than the open being correct, we only need to get the tokenizer directory using os make dirs if that directory has not been made yet. So this is not strictly necessary, but it is used in the NanoChat repository, and we are building NanoChat from scratch, right? So we want to ensure that, you know, we have the same checks that are occurring as is the case in that repo. And I don't know why I have this from re import I don't know what I was smoking when I wrote that line, but you guys should check past videos to see what I was smoking. Okay, so let's stop getting out of task. And now we have save implemented. So we're going to test this as soon as we implement load, because they're kind of complementary methods, right? So I should have also copy pasted load while I was there, but your boy lacked. And load is a factory method. Why is save not a factory method? It's because it does not return a tokenizer. We're saving a tokenizer. But when we load it, we need to give the user the tokenizer. So in that case, it is a class method. We're also going to change this to tokenizer dir, and then also call this from, what do we call it? From directory. So this is the convention once again for factory methods. This is how they're named. Okay, and we're going to use os again. So it's called pickle path in NanoChat. Pickle path gives us the directory that we want to query for the pickle tokenizer that was serialized. And so we're going to do an os path join of tokenizer underscore dir, which is the directory, and then tokenizer, this should be a string, dot pickle, which is the standard way that it's saved in our repo. And now I'm realizing that we didn't call it that here, so that's not good. So we need to make a new variable here, which is pickle path, right? Because if you guys notice here, this open would have opened a directory, but we want to open up a file, not a directory. And we use the same os.path.join of tokenizer dictionary, tokenizer dir. And since we're calling it tokenizer.pickle in the load, we should also call it that in the save. So now we should be golden, okay? And then here we change this to pickle path. And we no longer need to have our long pattern string here, because this is done for us in the regex tokenizer. We have the pattern splitting happening there. The only thing that we need, other than what is already here, is to load in the encoding object, because that is what represents the tokenizer in the tick token encoding class. So we have enc equals pickle dot load of f, and then we simply take this class, we instantiate a class which has enc as the first parameter, and then since it is from directory, this means that we trained it ourselves. we saved it and then trained it, then we will use the NanoChat string document delimiter. So now we have from and save, so we can hopefully load and save a tokenizer that we trained. So let's do this example here. So we have our tokenizer that we train for a vocab size of 300. It's obviously small, but it's a toy example. Then we do some encode, decode stuff. So let's, in the intermediary, right? Let's first save this. So we should just do tokenizer.save, and we need to give it the directory. Okay, so let's open up our file directory and see, okay, I'm always a noob with file handling. So I think if I do this, it will save it in the present directory. I hope so, at least. And then we will say that tokenizer, let's give this a different name, right? So we want to give this a different name. Why? So that we know that we're actually using the tokenizer that we loaded instead of this other tokenizer that we just made in the inline Python, to ensure that tokenizer.load is actually working. Sorry. And since this is, once again, a class method, we do it on the class itself, from directory, and then the directory, well, we're hoping that it's this. So the only thing left is to try and see if this works. But let's first clear our terminal. Okay. So it's saying no such file or directory dot /. Oh, okay. Why did I have that there? That's weird. Maybe it'll still give me an error though here. Did I not get an error? Wow. Okay. Boom. So what I should have done, right? Because I'm in the deep learning directory here, is I should have called this NanoChat. Because I don't want that to be in the large directory. I want it to be in the directory that I'm in. Okay, boom. So what you can see here is that we trained a tokenizer for 300, well, not 300, but like 256, 300 minus 256, like approximately 40 iterations. Then we saved it in the NanoChat directory under the name tokenizer.pickle. And then that was tokenizer 1, which is important. And then we instantiated tokenizer equal to the tokenizer.pickle in the NanoChat directory. And then we did all of this, which, like for here, we're checking that encode is the same as the encode forwarding call method, as well as just printing out the tokenized version of hello, I'm so happy today, and then encoding, decoding to make sure that hello, after being encoded and decoded, gives us the same object, since these are inverse functions, and it does. So now we have those methods done and out of the way. That's amazing. Now we're going to implement those two class methods that I mentioned at the beginning, which literally is just one line. And why are we doing this? This is just because these are the class methods that are used in the NanoChat repository itself, and they're also useful when we do benchmarking, which is what will be the finale of our tokenizer section to the series, to ensure that we are getting similar performance as is achieved by Karpathy himself, because we are using TikToken, right? So we should be getting the same performance. And the first get method just gives us the token vocabulary, and then the second gives us the set of special tokens. So get special underscore tokens of self, and come here. Instead of writing it down, I'm just going to be lazy and say this. I don't want to cut it. I want to copy it. So return self dot encode dot special tokens set. Okay. One thing that I just realized is that here we have it as n underscore vocab, but in the TikToken docs, it's called something else. But let's first just make sure these two work. So we have GPT-2, right? So we want to comment these out because I don't really need them. And we'll do print GPT-2 dot get special tokens, comma, GPT-2 dot get vocab size. And let's just see what happens. And I should probably call these, since they're methods, with those funny parentheses. Cool. So the special tokens is the same end of text, and the vocab size is 50257. Sanity check here. If I bring this pane back in to view, we get 4GPT2, 50257, and the, oh, that's R50K, so I guess it's the same thing though. And we also get the end text here as 50256. So I just realized like these have pretty much the same parameters. It just must have different mergeable ranks, but it has the same vocab size. So maybe it was, yeah, I actually don't know what the difference is between these. So maybe I'll look at this after the video and then satisfy my curiosity. But one thing that I wanted to check, right, is that for some reason here, it's called explicit and vocab size. So I wonder if I call it that here, if that'll give me an error, or if there's just somehow two names for the same thing in this library. Okay, yeah, so that's interesting. Maybe the nvocab is the name for the object in a different part of the repo, and that this is like just a illustrative for illustrative reasons, and it's not actually the proper name. But yeah, explicit nvocab isn't the correct key for the vocabulary, but that's just a funny artifact. What is important is that we now have these two get methods implemented, which will allow us later on to compare the vocab size of different models. And if we want to also, we can just check the tokenizer vocab length, which should be 300. So let's do this really quickly. Tokenizer1.get vocab size. Call that, boom. 300. All right, just like we wanted it. Now that we have this, we're going to jump into conversation rendering. So this is going to be the hardest part of the video today. So because of that, we're going to start with some conceptual explanations through examples, as we love to do in this series. So before I do that, I just want to make sure I don't mess anything up and give it the proper name. So if I come back here, it was render conversation. And one thing worth noting is that we have a 2048 context window by default in the NanoChat model. What else do you want me to say? So let's do this and then pass and then get into the examples. So as you may or may not know, there's a standard, or yeah, I think this is the standard way of representing chats, and it's done through a dictionary. So let me show you an example. So it usually goes, it's actually a list of dictionaries. It usually goes like this. You have role and then user, which would be like me or you. And then the content is what the user said. One thing worth noting is that usually the first element in the chat list is called system, which is like the system prompt. So that is something to keep in mind. But in this case, we are abstracting that and we're just saying user, and then the response will be by the assistant. And we're also having a mask that we're going to make over time. So what do I mean by a mask? I mean that we don't want to actually train the model on the user tokens, okay? So in the example, which I am in the process of copy pasting here for you, we have the following conversation. The user says hello, and then the assistant says hi there. So this should be tokenized in the following way. We have the beginning of sequence document delimiter, then user start, hello, user end, assistant start, hi there, assistant end. And then, as I mentioned, right, we have a mask. So this mask is saying all zeros for user, right? And then as soon as we get to the assistant, we have a bunch of ones. And then another thing is we have each special token encoded as 0. So assistant end is the 0 here. And then this is the tokenized version of hi there. And then all of these zeros is essentially from the beginning of hi there up to here. So what we're saying is that only assistant content is masked to 1, meaning that it's used for training. So what this means is that the model only learns to predict assistant tokens and not user tokens. It just uses those as context, so it can condition on them, but it does not actually train and calculate a loss on the user tokens or the special tokens. So what you call this is a training mask, and it just means that we only calculate loss on assistant generated tokens, since that's all the assistant does. So yeah, I hope this is a valid, or this is a sound explanation for what I'm trying to describe to you. Now, this is the vanilla case where we have text that's just like plain text, hello, hi there. The large language model used in NanoChat can also not only generate Python code, but it is also able to evaluate and literally like run Python code and then get the output from the Python interpreter. So now let's show how that works. So first of all, if you don't remember from the special tokens, which I'll just show you, there's a Python start and Python end, which invokes the Python REPL tool, and it just shows the Python code generated by the by the model, and it says like just another special token, right? So it generates hello.countL, and this would be for the case where you wanted to count the number of letters in a word, which is a notoriously difficult task for large language models. So you have Python start, Python end, and then it would call a tool here called calculator on this expression, and then it would output the result. So output start, output end, these represent the outputs of the Python code generated by the model. What I wanted to motivate is that we do set the mask equal to 1 for anything that's Python, which in NanoChat is represented by Python start, Python end. But if there's anything which is output start, output end, which is Python output, we mask this to 0 because essentially output start, output end is what is generated by Python. So it's a deterministic output, and we're not training the model to generate Python code, right? We have the Python interpreter to do that. Sorry, we are training it to generate Python code. We're not training it to evaluate Python code, right? So we want it to have a mask equal to 1 on Python generated code, but not on Python outputted code, because yeah, we don't want to train it on this. So this is another example where you would just be asking the model to add numbers. So the model would just generate the following text: Python start 1 2 3 plus 1 4 5 plus 4 5 6. Python is pretty much just a calculator, and then you would get the following 5 7 9 from this addition. And once again, we would mask the first sequence here as 1, because except for the special tokens, of course, because we want to train the model to generate these tokens when we ask it this question. So prior to this, there would have been probably user, what is 1 2 3 plus 4 5 6, and then assistant saying, okay, I'm going to call this, and then we get Python start, Python end, and then output start, output end. And only on assistant tokens and Python generated code tokens are we masking it with 1. And one more thing is that after this, of course, the model would continue. It sees the output that itself it generated with Python and would probably come with a assistant output saying the answer is 579. So now we're going to delete this and implement the function. I didn't mention though that this is a very long function. So instead of writing it in a protracted manner, I'm going to copy paste the atomic parts one by one so that we understand each part without having to spend ages writing it. Okay, so this is the initial section of the code. Let's look at what the doc string is. It says tokenize a single chat conversation, which we call a doc or document. So, and it returns a ID, which is a list of tokens of this conversation with all of the special tokens, everything. And then a list of the same length called mask, and mask is equal to 1 for tokens that the assistant is expected to train on. So we initialize these to empty lists at the beginning, and then we have what you would call, I don't know what this is called, but it's a helper function within our method. And all it does is that every single time we want to add some token to the IDs and the masks, we will add that token ID and then ask that add that mask value, and then just call the function itself, and it will add it both to ID and masks. One thing you'll see here is that it's quite cool. If we have a token, this actually works for a list of tokens. If we have kind of 10 tokens and they're all mask 1, then it will just extend it by the length of the number of tokens we have, and then we just use the standard extend for the IDs. One thing worth noting here is that we have a check to see if there's only one token ID, because then it would have a value of int. So we'll just make it a list of length 1 so that we are still able to use extend. So this is pretty standard. Now let's get into like the core logic itself. This is here, the first step. So if the first message is a system message, remember I talked about system messages at the very beginning, then we'll merge it with the second user message. And what I mean, or what it's meant here is, in order to avoid like having separate logic that deals with system messages, we'll instead create a copy of the conversation. Why is this done? It's to prevent downstream undefined behavior by modifying the conversation, since you do modify these in place in Python. So we take the conversation and then get the messages of that conversation. So I took this out, but I do want to keep one list here for your own intuition throughout this explanation. And which list, or it's not a list, it's a dictionary. Am I talking about? I'm talking about here. So in this case, the conversation is a dictionary with the messages in there. So we want to index the messages, get the 0th item, which would be here. This is a list, right? And then check if the role is equal to system. So I didn't mention the if statement here, but that's that. And then what we need to say is that we have to assert that the next role is a user, right? Because if you have a system message as a system prompt, it has to be a user after that. So we're just making sure that we're not shooting ourselves in the foot by having a system followed by assistant, which doesn't make any sense. And if that's the case, then we will take the second user message, right? Right here, how does it say? Yeah, the second user message, and then we will add the system prompt to it, and then make that the new first message, or the 0th message, right? By essentially indexing messages from 1 instead of from 0. So once again, we take message 1 content, we add the message 0 content so that we're not losing it when we essentially delete the 0 content, and then we add 2 lines in between them, and then we go on with our day just to handle the case where a system message is in our conversation. Okay, so now let's print some more. Otherwise, the messages are just the conversation messages, right? If there's no system messages, then we still want to grab this list and use this for the rest of the conversation construction process. Okay. One thing worth noting too is that if you have a message that is not greater than or equal to length 1, then there's not much to do, right? You need to have at least one user query to tokenize it and then feed that to the large language model so that it can generate the assistant output. So we need to make this apparent. And then we need to also, but it's convenient to fetch all of the special tokens. And this is just by using self.encode_special. Since we did make the get method for the beginning of sequence token separately, then we can just grab that here. And in theory, right, you could just, to be more efficient, wait until you're sure that there's a specific code block that will require either Python or output tokenization. So you don't have to call self.encode_special here, but that's like a really, really small optimization. And we all know that premature optimization is the root of all evil. So this is all kind of like setup that we've done up to now. Now we want to actually get into the tokenization part itself, where we are building this conversation part by part. And I said part because that's how we refer to the different parts of the conversation in certain sections of this method, but we haven't got there yet. So just ignore what I said. First of all, we add the beginning of sequence token with 0 because we don't want to train on it, right? This is the mask. This is the first token in any document. And then now we're going to enumerate over the messages. So one thing that we're going to define here is must be, right? And every loop, it will be user if it's an even index, and then assistant if it's an odd index. And why is this the case? It's because the user always asks the first question. And even when we have a system prompt, we still make it a user role because we append them. So this is just something to avoid footguns, as Karpathy says. And then we just have an assert here, which will tell us that you are in the wrong conversation if must be from is the incorrect token. Okay. And now we're going to grab the content, which if we come back here is this part of the message. So in this case it would be hello if we're talking about the first index in our conversation, in our messages list. Okay, so let's get back to where we were, right? We were here. oh, sorry, we got the content, and now we're checking if it's a user. So if it's a user, we will say user message. If it's not a string, right, we'll say that user messages are only supposed to be strings. As a user, when you ask the model something, you can only really talk in strings. Even if you have numbers, right, it'll be represented as a string. And then if that's the case, we add the user start token, special token, this one. Then we will add the actual encoded values, which are strings. So we don't need to do any strange special token stuff. And then we will add the user end, right here. And that's all. So now let's go to what the assistant does. And this is much more involved. So I'm honestly just gonna copy paste everything from the function now because it's kind of just like one really long elif statement, like this one right here, right? So you have all of this, okay? And let's go through it part by part. So that's what I was talking about when I said part. So if it's an assistant, then before we do anything, we're just gonna add the assistant start token. And then we're gonna check, is this a string? So if the output of the model is just a string, then we're lucky because we don't have to talk about anything with Python or outputting code, right? So we'll just encode and add the IDs that we tokenized. And once again, we're using this really nice help function to do that, which adds both to the IDs and to the mask list, which we return at the end of the function. Okay, and then now, these are the more nuanced cases, right? So if it is a list as opposed to a string, then what this means is there are some Python tool calls or other, let's go through all of the options, right? It's either Python output, or text. So some other things happening within the assistant output. And of course, when this elif is called, this means that this was not successful, right? It was not just string, but I didn't mention that if it is just string, we'll go straight to add tokens for assistant end, which is here, and be done with it unless we have an unknown type. So I just wanted to highlight that since that is quite a helpful comment. So given that we're encoding a list here, I have written in code what this would look like. So instead of saying content equals hi there, which was the case before, we now have in this instance a list of element 2 with the first one being type text and the text being hi there, and then the second one being type Python and the text being some Python expression. So text just means content in this instance. And now we'll be able to better understand what's going on here. So for each of these two elements, we'll first encode the text, right? So in this case, we'll encode hi there. In this case, we'll encode the Python generated code. And then if the part was a Python expression, right? Then we'll add the Python start and add the Python end tokens with the value IDs in between. If it was a Python output, we'll do the exact same thing. So let's look at what this says. Add the tokens inside output start and output end in between. None of these tokens are supervised because the tokens come from Python at test time. It's non-deterministic. It's just evaluating the Python code. And then Python output looks like this is the Python output of the Python generated by the LLM. And that's correct, right? This is the this is output of the Python code generated by the LLM. So we don't have anything here, but that would be if in this case we have Python out. But one thing worth noting is that Python out always succeeds Python standard, which is Python generated code, or rather Python always precedes Python out. So that's something that you need to know because you can't have Python output without some generated code to evaluate. And then if nothing else happened, then it's not an ID, it's not a integer, it's not a list, it's not a string, then you have something wrong and you should raise an error. And it can't be an integer because we're encoding, right? We want to return integers in the IDs, but it can either be only a list or a string. And then if this else, so let's go back up here. This else here maps to the if and elif for list and string. So that's the case that I was just mentioning. And then the else, in fact, is talking about the elements in the part. So if it was not a Python output, a Python, or a text, then something's wrong and it's an unknown part type. At the end, we will take our IDs and mask and then truncate them by the max number of tokens, which in this case is 2048 by default, and then return the IDs and the mask. So honestly, it's a long function, but at least in my opinion, when you look at when you go through it part by part like we just did, it is very tractable to understand. And finally, we have one last function, which is render underscore for completion. And what does this do? First, it takes a self argument, since it is a class method, and the conversation. So running a conversation for reinforcement learning completion. So it just removes the last assistant message of a generated message by the model, and then appends assistant start to try to elicit another response, right? So in reinforcement learning, you're continuously generating different reasoning traces, right? So when you generate one reasoning trace, you want to delete that reasoning trace once you've trained on it and then generate another one. So let's do that right now. First, we're going to, since we are going to modify the conversation by deleting the reasoning trace that we do get, we want to copy that. So I don't know if I imported deep copy. I did not, I don't think. Yes, I did not. So let's also import deep copy so that we don't get errors when we test this, because we are going to do just that. Where do I have all the imports? Okay. Boom. And what did it give me? Okay. Looks like I'll have to do a little UV add deep copy. It's not in the Python standard library. What the heck? Deep copy was not found in the package registry. Okay. I don't know why that's the case. Hopefully this will resolve itself, but we're gonna figure that out when we get there. For the time being, let's continue to implement this function. So we want to grab the messages, right? So we're gonna take messages equals conversation messages. This is the messages list. Should be pretty familiar with that by now. If you're not, then I'm going to copy paste this down here because we're gonna need it anyways. So let's go like that. And one thing that I'll say is conversation, what I'm going to do here is I'm going to load up conversation here and then uncomment it. So this is the messages list, because we'll need that to input this function, right? Because we want to test it. And we're going to call the function down in the bottom where we have all of our different tests. So one thing that you want to check is first that the last element in the message list is of type assistant, or else something's wrong. Role is of type assistant, right? Because it's the key is role and then the value is assistant. So we're first going to check this, and then in that case we're just going to pop that up. Okay, and we also need to tokenize this again so that we add the assistant special token back to it. So we're going to call the function that we just made, render conversation, self.render conversation on the conversation. And we're just going to assume that the maximum, the amount of tokens is 2048. Okay. And then we want to return IDs because we want the encoded result. And just upon further deliberation and verification, we are still adding the assistant start token to the end of the sequence. So I just realized that this conversation is untokenized, right? So the origin of this function, don't quiz me on this because I haven't implemented it yet, but somehow we're getting a function that is in the Python dictionary form, right? And also has a reasoning trace. We want to remove that reasoning trace and then add the assistant token, start token back to it, and then feed it back to the LLM. Okay, so in order to do this, we first need to encode the assistant start token. So assistant start equals self dot encode special of, I'm just going to write it down. I think it's this assistant underscore start. Okay, so this is assistant start token. And then we just do IDs dot append this token so that we have the desired setting. Okay, boom. And then we return IDs. So this should be everything we need. The only thing is, once again, I don't know why. First of all, I spelled conversation wrong here, but that's fine. I don't know why this is not being recognized. So let's just call this, and then if it actually doesn't work, then I'll probably have to go off camera to see why I have dependency issues for this instance. Okay, so first things first, I need to get rid of this because I don't actually have a Python expression to evaluate. So it'll just be a list of length 1. And then, so we have this conversation, right? We'll see if everything works now. This is the moment of truth. Let's do it at the bottom. So we'll do print. Let's do this with our tokenizer 1 that we loaded. Dot render for completion for reinforcement learning. And this takes a conversation, which we have there. So I assume this will give us an error because we don't have that deep copy working. NanoChat bpe.py. Ah, okay, we have a different error, so I'm happy that with this. And it's just because I didn't do a double equality. Oh, I didn't even add it at the right place either. Jeez. Okay. No module name deep copy. Okay, I just want to see if I can solve this in real time. I prefer to do that. No solution. Okay, what if, I know it's not copy, but yeah, why isn't UV add deep copy working? What if I do UV pip install deep copy? Okay, I'm still gonna solve this in real time because that's the whole spirit of the series. So I'm gonna say how to install deep copy. I hope this will, okay, it is included. Ah, shoot. Okay, it's because I wasn't importing copy, I was importing deep copy. Right, it's copy. You always have to import the first argument in the function, sorry, in the package declaration. So I think you guys were all cringing at me for that, so sorry. And it's part of the Python standard library. Jeez, man. Okay, let's see what's going on here. Line 34. Where did this come from? I didn't even write this. This is so weird. Okay. So that's a good error. It just means that I have an incorrect function name, and I think it's because I called the BOS token ID function BOS token ID instead of get BOS token ID. Or did I not implement this function? I did not. Okay, so we're supposed to have a get BOS token ID function, which just returns the object here. So, geez, guys, I'm really off of my game, but def get underscore BOS underscore token underscore ID of self is return self. Whoop. There you go. Got it. Got it. Ha ha. Okay, so what did we even do? I don't even know what we did. Let's see what we did. So I don't know what this, I don't know. Okay, like the entire thing we want to see here is did the render for completion work, right? I don't know what this represents, so I'm gonna decode it, and then we'll see what that represents. Decode. Cool. So just as we wanted it, we had this conversation, right? So I'll show you what it should look like, right? So print tokenizer dot render for conversation, right, of the conversation, and then I'll just show you what the tokenized version looks like first. It's pretty long, right? And we also get that that really cool mask, which tells us that we're only trading on assistant tokens. But then I want to decode this so we see what it looks like in text that humans can understand. Are we not allowed to decode lists? Hold on. Let's go back here. I mean, it is just implemented in decode, right? So what's the problem here, guys? Why isn't this working? Let's look at what we had before, right? Ah, it's because we get the mask and the IDs. So I only want to give it the IDs. So I need to get 0 here. I think so. What? Okay. I'm just going to call this a new variable because I always get confused when I start to do these fancy multi-parentheses function calls. So let's just print conversation and see what we get. And I shouldn't be calling this conversation because now I'm overwriting the name. Jesus, man. ABC is the name. What a genius name. Okay, that's this. And it does give us what we want, which is the tokenized list, right? And I think maybe it's because we have some special token error here that it's getting mad at me. Oh, okay, never mind. It's fine. Okay, so the conversation that we rendered is this. So it's just saying hello and then hi there. That's really cool. I wish I could add back that Python stuff, but I don't really want to because we didn't have a Python expression to begin with. Okay, and then when we remove the assistant start, we get nothing there. So assistant start is empty. That's really cool. That's pretty much everything that I want to talk about in today's video. I now do feel slightly inspired to add what I just said I didn't want to add. So let's see here if we have it in our history. Okay, I do have it here. Okay, and then I think let's call it Python out, and let's call it text. We'll just, okay, we're not gonna actually give it Python as the out because we're just tokenizing here, we don't really care, but, right, unnamed part-time Python out. I don't know why that's happening, let's just call it Python instead, because maybe I spelled Python out wrong. Cool, so now we can see the tokenization with Python, and we get this. This is of course not Python, but it doesn't really matter. And you can see how the assistant is at the left and the right of both the text here and then the Python. So the text does not have its own special token, but the Python does. That was a long video, but I hope you guys enjoyed. We're really almost done with NanoChatTokenizer. There's only one more video where we need to implement a few helper functions, and then I hope we can do the same. We can do some tests in that same video because there are a lot of tests that Karpathy implements in NanoChat to ensure that the tokenizer is working properly. So stay tuned for that video and have a nice day.